So here we are with lesson 18 for unit 4. There is only one line passing through a given point with a given slope. So for the opening exercise, complete exercises A through D on the lesson worksheet and then continue the video. Alright, you should have exercises A through D completed. So for A, B, C, and D, you need to identify what is the y-intercept. The y-intercept. And at this point it would be 0, 3. For B it would be 0, 7. For C it would be 0, negative 2. And for D it would be 0, negative 4. So in each equation, the number B was the y-coordinate of the point where the line intersects the y-axis. It also asked you to identify where on the graph the point is that crosses the y-axis. So for A, I've marked the point here. B, the point here is 7. For C, the point here is negative 2. And for D, the point is negative 4. Alright, so in your journal, let's talk about what our opening exercise is trying to do. So in the last lesson, we transformed the standard form of a linear equation, ax plus by equals c, into what was referred to as a slope-intercept form, y equals mx plus b. We know that the slope is represented by m, but we did not discuss the meaning of b. In the opening exercise, you were asked to note the location, or ordered pair, that describes where the line intersected the y-axis. What did you notice about the value of b in relation to the point where the graph of the equation intersected the y-axis? The value of b was the same number as the y-coordinate of each location. So when a linear equation is in the form of y equals mx plus b, it is known as the slope-intercept form because this form provides information about the slope, m, and the y-intercept, 0b, of the graph. The y-intercept is defined as a location on the graph where a line intersects the y-axis. In this lesson, we developed the last tool that we need in order to prove that the graph of a linear equation in two variables, ax plus by equals c, where a, b, and c are constants, is a straight line. We will show that if two straight lines have the same slope and pass through the same point, then they are the same line. Since an equation of the form y equals mx plus b provides information about both the y-intercept and slope, we will use this equation to graph lines. Recall that we began discussing slope graphically. That as we move across the x-axis, we measure the distance of the y between r and q. So as we move across from P to Q, we measure the distance from R to Q. Alright, for example 1, graph an equation in the form of y equals mx plus b. So for example 1, we're going to graph the equation y equals 2/3 x plus 1. Name the slope and the y-intercept. Well, the slope is m equals 2/3, and the y-intercept is 0, 1. So to graph the equation, we must begin with the known point. In this case, that is the y-intercept. We cannot begin with the slope because the slope describes the rate of change between 2 points. That means we need to have a point to begin with. So on a graph, we plot the point 0, 1. Which is right here. Next, we use the point to find the second point. The slope tells us exactly how many units to go to the right to find point Q, and then how many vertical units we need to go from Q to find point R. How many units will we go to the right in order to find point Q, and how do you know? Well, we need to go 3 units to the right of point P to find Q. We go 3 units because the distance from P to Q is 3. So here is our Q point. So how many vertical units from point Q must we go to find point R? And how do you know? Well, we need to go 2 units from point Q to find R, and we go 2 units because the distance from Q to R is 2. We will go up from point Q or down from point Q to find R, and how do you know? Well, we need to go up because the slope is positive. That means that the line will be left to right inclining. And here is our illustration. So R is going to be 2 units above Q because it is a positive slope. So since we know that the line joining 2 distinct points of the form y equals mx plus b has a slope of m, and we specifically constructed points P and R with the slope in mind, we can join the points with a line. All right, let's take a look at example 2. Graph an equation in the form of y equals mx plus b. And for example 2, we're going to graph the equation y equals -3/4 x minus 2. Let's start off by naming the slope and the y-intercept. Well, the slope is m equals -3/4, and the y-intercept is 0, -2. So how do we begin? Well, we must begin by putting a known point on the graph, which would be 0, -2. So how many units will we go to the right in order to find Q? And how do you know? So here is our y-intercept at 0, -2. That is our point P. Well, we need to go 4 units to the right of point P to find Q. We go 4 units because the distance between P and Q is 4. So here we are. How many units from point Q must we go to find point R? And how do you know that? Well, we need to go 3 units from point Q to find R. We go the 3 units because the distance of Q to R is 3. So will we go up from point Q or down from point Q to find R? And how do you know? Well, in this case, we need to go down from point Q to point R because the slope is negative. That means that the line will be left to right declining. So instead of going up, we are going down. The reason why we didn't say -3 is because when we talk about distance, distance is always positive. But notice that the second question we asked is, are we going up or down? So the distance is still positive, it's just the direction we are going is going to be down. So now we draw the line through points P and R, and we get our left to right declining line. All right, example 3. Again, we're going to graph the equation. And this equation is going to be y equals 4x minus 7. And starting off, name the slope and y-intercept. Well, the slope is m equals 4, and the y-intercept is 0, -7. So, how do we begin? We must begin by putting a known point on the graph of 0, -7. Notice this time that the slope of the integer, or is the integer 4. In the last 2 examples, our slopes have been in the form of a fraction so that we can use the information in the numerator and denominator to determine the lengths of PQ and the length of QR. Well, if m is equal to the length of QR over PQ, and that equals 4, then what fraction can we use to represent slope to help us graph? Well, the number 4 is equivalent to the fraction 4 over 1. So how many units will we go to the right in order to find point Q? And how do you know this? Well, we need to go 1 unit to the right of point P to find Q, and we go 1 unit because the length of PQ is 1. So here is our illustration. 1 unit to the right of P is our Q, so the distance is PQ is 1. So how many vertical units from point Q must we go to find point R, and how do you know? Well, we need to go 4 units from point Q to find R, and we go those 4 units because the distance of Q to R is 4. Will we go up from point Q or down from point Q to find R? How do you know this? Well, we need to go up from point Q to point R because the slope is positive. That means that the line will be left to right inclining. So here is our illustration, putting R 4 points away from Q. So now we join the points P and R to make our line. And here you go. All right, go ahead and do exercises 1 through 6, and then continue the video to check your answers. All right, you should be done with exercises 1 through 6. Number 1, identifying the slope and the y-intercept, and then graphing the points using point Q. So make sure you are showing your work by showing the distance between P and Q and between Q and R. Here is the answer to number 2. And the answer to number 3. And the answer to number 4. Again, if you have any questions about any of these answers, please make sure you write them down and bring them to class. Answers 5. And for number 6. All right, so let's wrap up. We know that in the equation y equals mx plus b, the coordinate 0, b is the location of the graph where the line intersects with the y-axis. We know how to graph a line using a point, namely the y-intercept and the slope. We know that where there is only one line with a given slope passing through a given point. All right, see you in class.